Question 35. You've got the diagram down here for the dart. So we're going to just look at this in vertical and horizontal in turn. If we start with vertical, and the initial speed vertically is 0 because it says it's throwing it horizontally. We don't care about the final velocity. The distance that it's going to travel, is the distance it's going to move downwards there to there. So I'm going to put that as minus d because I'm talking about going up. The acceleration is acceleration due to gravity, so that's minus g. And I'm going to try and find out what the time is there. I'm going to use an s equals ut plus half at squared to do it. And so I've got minus d equals, well, this is just 0 because u is 0. So I've got minus a half gt squared. Minus because I've got a minus g there. So look, the minuses didn't matter in the end there. The minuses are going to cancel out. And rearranging, I can see that t is equal to 2d divided by g square rooted. And that's the time it takes for the dart to get to that point there. Now let's go horizontally, because horizontally it's going at u meters per second to start with, and the time it's traveling we've just got from there. And of course horizontally we assume there's no acceleration at all, so s is just equal to ut plus 0. So the distance traveled is r, is equal to u times t, which is what we've just got there. And the question asks us to find out what r is, and there you go, we've done it. There's the answer. For part B, we're just told that the speed starts at 11.2 and the distance that it was thrown from is 2.25. So I'm just going to put that in there. 2.25 equals 11.2, the square root of 2d over g. So we'll divide by 11.2, we'll square it, we'll times by g and divide by 2, and that gives me d to equal, I've got 0.1977 meters. So basically about 19.8 centimeters. So the way through that one there is just take two things individually, first of all vertically and then work through horizontally as well.